All right, I stopped recording for some reason. I don't know. All right, functions are 12 to 15%. That would be like linear, radical, piecewise, polynomial, log functions. So any of the log things are going to happen in functions. Do you guys remember how to convert from log to exponential functions? 2 to the third power equals 8. That's exponential. How do you make it a log? Log base, what's the little subscript number? What? Log base 2 of 8 equals 3. The base of the exponential function is 2. The base of the log function is also going to be 2, okay? The first two numbers stay in the same spot, and then these two numbers switch, right? It was 3, and then it's 8. Now it's 8, and then it's 3, okay? Logs versus exponential functions. There you go. Geometry, shapes and solids, surface area versus volume. Most of the time, if it's a really intricate volume surface area, like my geometry kids you're doing right now, they will a lot of times give you the surface area and volume equations. They don't expect you to memorize those. The ones that they do expect you to memorize are the area of a rectangle, the area of a triangle, the area of a circle, and maybe that's it. How do you find the area of a rectangle? Yeah, base times height or length times width. That's the area. Base times height. How do you find the area of a triangle? Half of that. Half of base times height. Okay? How do you find the area of a circle? Pi r squared. Yep. So you should have those memorized. Anything beyond, like too much beyond that, they're going to give you that. Okay? Congruent and similar figures. Do you remember similar figures? Here's an example of similar figures. Okay? I have a mailbox and I have a tree. Okay? And the shadow on the mailbox is 5 feet and the shadow on the tree is 15 feet. And the mailbox is 4 feet high. How tall is the tree? Right? You can just see how that works because it's multiplied by 3, right? Okay, but if you don't see that, you can do a proportion. So like 4 over 5 equals x over 15, right? And then you can cross multiply and divide. Okay, so there's strategy for that. Geometry. Congruent, similar, trig ratios, triangles, and circles. So your SOHCAHTOA stuff is going to be in there. All right. Statistics and probability, center spread. This would be like mean, median, mode, range, that stuff. And calculating probabilities. Let's keep it going. Here is ACT content covered. You have 45 to 50% is interpretation of data, scientific investigation, and evaluation of models. You can read through that if you want to, but there's that. Okay, final takeaways, wrap up. Integrating ACT multiple choice questions into your, okay, never mind, that's for me. You don't need to know that. Okay? All right, let's go to the last 5 questions. Here we go. 56, I think is the one we're on. Look at those answer choices. How ugly. Bleh. Okay, but what I noticed from those answer choices is that none of them are solved for, right? Okay, at Heartland Community Hospital, identification codes consist of the following sequence: 1 digit, 5 letters, 2 digits. For any one code, the digits 0 through 9 may be the same, but the letters from each English alphabet must be different. Which of the following expressions gives the probability that a random selected identification code contains the word HEART spelled correctly? What? 1 digit, 5 letters, 2 digits. That's disgusting. 1 digit, 5 letters. This is my 5 letters and 2 digits. Okay, for any one code, the digits 0 through 9 may be the same. So there's 10 numbers that could be here, right? 10 numbers that could be here and 10 numbers that could be here. Maybe? Right? Those are my digits. Letters. I cannot repeat any letters. So this guy could be 26 different letters. This guy could be 25 different letters, 24, 23, 22. And then that. Okay. So if I'm looking at this, I see a 10 to the third power times 26, 25, 24, 23, 22. Okay, I can cross off some answer choices at this point. I know it's not F. because that's 26 to the 5th power. That's not going to work, right? Because it's got to be like going downhill. G might be up for grabs because I have 10 to the 3rd and I have that stuff going on. This one, I know it's not because 10, 9, 8, right? I can use any of the 10 numbers. Those can repeat, so it's not going to be H. What about J? In or out? I think J is out because 26 to the 5th power. Not going to work. I think K is out because 10, 9, 8. You can repeat the digits. So I don't even really know what this thing means, but I know that it's got the pieces or the elements of here that I need. Okay, whatever. Now, I guess the reason why I have 10 to the 3rd power over 10 to the 3rd power is because we want the word heart in there, so I want this to be H-E-A-R-T. I don't care what these numbers are. So that's why these two would end up canceling with each other. So I have a 1 in this 26, 25, 24, 23, 22 chance of spelling the word heart exactly. Whatever. But I did that by process of elimination. I know that it has to have those pieces in there. Okay, let's go to the next one. 57. A triangle in a circle, is drawn in a circle on an XY coordinate plane is shown if the circle with center CD intersects the x-axis at a point -2, 0. If the circle with center CD, this is the center, intersects the x-axis at -2, 0. So this guy right here is -2, 0. And 8, 0. Yeah, 8, 0. And the y-axis at A, B. So it's intersecting there at A, B. What is B plus C? Interesting. Interesting. Okay. All right. We got this. We got this. All right. How far is it from here to here? 10. How far is the radius? 5. Okay. That means this right here is also 5. Yeah? Okay. All right. If this is 5 right here, and this is how much? 2. Then this right here is 3. So what's this height right here? 4. That's a 3, 4, 5 triangle, right? Okay. So this point right here, A, B is 0, 4. Yeah, because it's 4 units in the air. Okay, what is C, D? So A is 0, B is 4, C, D is how much? 3, because like the radius would be 8, or a radius would be 5. So C, D is 3, 0. What is B plus C? B is 4, C is 3, 7? 7. Okay. Here's an example again of how they list them in order. 7, 5, 4, 3, 0. Okay, they're always going to be in order. However, okay, good. That was just kind of like a process of elimination. That again, no calculator. No calculator at all. 58. What is the maximum value of that thing for each set of positive real numbers J, M, P? Ooh, this one's tough. What are we doing here? For each set of positive real numbers J, M, P, what is the maximum value? What the heck? What is the maximum value? This is like where we plug dang numbers in. What? P's got to be plus. Yeah. So, like cross off F and G, you think? Or not? Because all the P's would be pluses. But the absolute value of this thing what is the maximum value for each set of positive real numbers J, M, P?
I would guess.
I know. This one was like one I would probably guess for too. Should we plug in numbers for J, M, P for each set of positive real numbers? Okay, let's say J is 2, M is 3, P is 4. negative absolute value x squared minus 2 times 2, which is 4, plus 3 absolute value plus 4. Okay, this guy would be negative x squared minus 1 plus 4. I don't know. What? Will Phonomath do it?
Send it to my AI.
Oh.
See if they'll fix it.
I'm a bit puzzled. I don't know what they're asking for. What is a maximum value? This is a skip because we've gone past our 15-second mark. For each set of positive real numbers, 2, 3, 4, I plugged in
Did
for
not do it.
JMP. Oh, that's a cube, by the way, not a square. X cubed minus 1.
Oh, no, it'd be, yeah, I think it'd be G plus P.
J plus M plus P. I'm wondering if M needs to be negative, though. Because once you pop it out of the absolute value, he will be a positive, but then you strap a negative onto it.
Well, it doesn't matter if it's negative or positive, because when it comes out of absolute value, it's going to be positive anyway.
It just said P equals 3.
We want the number inside that absolute value to be as low as possible. So it takes the least amount.
Right. Okay. What you just said. You want this absolute value to be as low as possible so that when you're subtracting that value from P,
That's why it's so good in the trick.
it's as low as possible. Well, but what's the lowest you can get and still have an absolute value? 0, right? So if this comes out to be 0, you have negative absolute value of 0 plus P. So the maximum value you would get is going to be P.
Oh.
Make sense? Yeah. The lowest value you could get. Okay, so that makes sense now. Okay, we had to think about it for a minute. Okay, absolute value. The smallest number and absolute, I don't care what these numbers are right here. The smallest value that could be is 0, right? It can't be a negative coming out of an absolute value. The smallest that could be is 0. And so basically I have negative 0 plus P, whatever P ends up being, right? And negative 0 plus P is going to give me the highest value because I'm subtracting the lowest value. And so the answer would be H. That was a tough one. That made me think a little
Probably
bit.
would have taken me 60 minutes.
Yeah, that was definitely a skip one. Okay, 59 though is an easy one. In the complex number system where I squared equals negative 1, we knew that already, but they're giving it to us. What complex number X is a solution to the equation of this stuff? Okay. X times 3 minus 5I equals 1. I want it to be a solution. What'd you say?
Distribute it and square it all.
Distribute and then square both sides?
Yeah.
Is that what you're thinking?
Yeah.
Like 3x plus 5ix equals 1?
Yeah.
What did that even mean?
What'd you say?
Square.
Yeah, it should be negative.
Oh, sorry. Yeah, negative. You're right.
Good job, Bill.
You're right. These ones are tough.
Hey!
What?
I'm a bit puzzled. In the
Billy
complex
did
number
that.
system where I squared equals negative 1, what complex number is a solution to the equation blah, blah, blah?
Oh.
Do you have a thought?
I still think square. And then move the 1 over and change it to.
Oh, I think I know what they're doing. Okay, all right, check this out. X times 3 minus 5i. We're not going to multiply it. Divide this guy over. x equals 1 divided by 3 minus 5i, but it is improper to have an I in the bottom. So you multiply by 3 plus 5i, which is a conjugate, right? Multiply by 3 plus 5i, okay? So on the top, if I multiply by 1, I distribute that 1 through, right? And I get 3 plus 5i on the top. But on the bottom, do we do this in trig, I think?
Yeah.
Yeah? Okay, 3 times 3 is 9. 3 times 5i is 15i. But then negative 5i times 3 is negative 15i. Do you know what negative 5i times positive 5i is? Negative 25i squared. But what's I squared equal to? Negative 1, so this is plus 25. So these two cancel. So I have 3 plus 5i on the top over 9 plus 25, which is 34. Okay, so I got 3 plus 5i over 34. Which answer choice is that? B. Right? They just wrote it as two separate pieces. Yeah? Yeah? That's what they're doing right there. Okay, so solving for x, don't distribute it through. We're dividing it over, and then we're multiplying by the conjugate. These last 5. The first 5 when we did the other day, I was like, oh, that's not that bad. Whew, these last 5 are a doozy. Okay, last one, number 60. Suppose the equations of this guy. Do you know what this is? What does this look like if you graph it?
Circle.
That's a circle. The center of the circle is 9, comma, negative 3, and the radius is 5. Okay, do you know what this thing is? That's an ellipse. That's an oval. Yeah. So the deal here is the center of the ellipse. So this guy is an ellipse. The center of him is at, what do you think? If you had to guess.
4, 3.
Negative 4, negative 3. Okay. But for an ellipse, so negative 4, negative 3 is down here, right? For an ellipse, it goes different units in the x direction than it does in the y direction. So like maybe he's like this, right? Where he's shorter this way than he is this way, okay? Do you know how you determine which way he is in which direction? How many units is he in the x direction? 3. So 3 units this way, 3 units this way. How many units is he in the y direction? 9. So he is an oval that looks like this, okay? So I'm going to say the radius in the x direction is 3, the radius in the y direction is 9. Okay, that's how that works. How many points of intersection do these graphs share? Boo. So there's that. And I've got 9, negative 3, and a radius of 5. Is it 2? I think it's 0. I think it's 0. I don't know, 9, negative 3. So this is 9, negative 3 with a radius of 5. So over here, it would be, my furthest to the left would be 4, negative 3, right? That's the furthest to the left he's going to go. This guy is at negative 4, negative 3. So negative 4, negative 3. But in the x direction, he's only going over 3 units, right? I don't think those are going to touch each other. You see that? So 0 points of intersection, I think. Yeah?
I think I would have guessed.
You think you would have guessed?
I would've said
Now,
about EA.
I can cross off a couple answer choices. Well, not necessarily. I was going to say, like, they shouldn't intersect at 3 places unless
They can.
it's doing one of these. I'm trying to think. Like oval like this, right? That would be 3 places, right? 1, 2, 3. Can they intersect at 4 places? Yeah. Like oval, circle, that's 4 places of intersection, right? Can they intersect at 2 places?
Yeah.
Oval, circle, right? Wherever, okay? And 1, can they intersect at 1 place?
Yes.
Yeah, if they're like touching, like butt up against each other, right? Like that. Whoop. Yeah, yeah. Yes, yes. Okay, so there's that, right? That one's just kind of a graphing and figuring out. We kind of made a mess of it. Okay. Ooh, those last 5. Ooh, that was tough. All right, there you go.